Okay guys, let's begin section 8.3 here, graphing f of x equals ax squared plus bx plus c. In 8.1 and 8.2 we looked at just ax squared, and then we looked at ax squared plus c, a vertical shift up or down. A represented some kind of vertical stretch or shrink. Okay, now we're going to add this thing called a bx term. So we're going to look at a quadratic function in the form of ax squared plus bx plus c. So this also will make a parabola, just like our other ones. And we want to follow this process as we go about it. So it's best learned by looking at example. Let's look at an example here. F of x equals 2x squared plus 8x minus 1. Well, whenever we see one of these in this form, we want to begin with this idea of the axis of symmetry. And I've abbreviated it here, AOS. You'll hear me refer to it as the AOS. And remember, that's the line that goes through our vertex, and then our parabola is symmetrical about it. Okay, so x here equals negative b over 2a. I'm going to box that in. This is a super important beginning point for all of these. Okay, and remember, a refers to the coefficient here in front of the x squared, b refers to the coefficient in front of x, and c is this constant term out here, negative 1. Okay, so let's go ahead and plug in and do that. X equals negative, my b is 8, I'm going to plug in 8, over 2 times a, my a coefficient is 2. So that becomes negative 8 over 4, which becomes negative 2. Okay. All right, so that's our axis of symmetry. And we always want to begin there. And if, say, we were making a graph, we'd want to put that in first. Okay, so once I have that axis of symmetry, that's the first thing I want to say dot in on my graph here at x equal to negative 2, which is a vertical line here at negative 2. And we always want to label that my AOS, and that's x equal to negative 2. Okay. So again, when we see these in the form ax squared plus bx plus c, we need to do x equals negative b over 2a. This is vitally important to begin. And that is essentially your axis of symmetry. Once we have that x value, then I can find the y value of the vertex. F of negative 2, 2, negative 2 squared plus 8 times negative 2 minus 1. Negative 2 squared, positive 4. That would be 8 minus 16 minus 1. Addition and subtraction is commutative, so we can do it in any order. 8 minus 16 is negative 8, minus 1, negative 9. So I know, 1, 2, 3, I'm down here at negative negative 2, negative 9, okay, and that's my vertex. And we want to label that as well. So negative 2, negative 9. All right, so once I have that axis of symmetry, x equal to negative 2, I take that value, I plug it in for x, and in this case, you plug in for every x in the function. So notice I plugged in for x, and then I squared it, and then I also plugged in x there as well. And then I have then my y value, my x and y value of my vertex, and I want to label that. Okay, so once we have, say, our axis of symmetry and our vertex, let me go ahead and erase here. Well, then I want to ask myself which way the parabola opens. Well, there's an easy way to tell. Well, I'm going to look up here at my a coefficient here. And if a is greater than 0, it's going to open upward. And if a is less than 0, it's going to open downwards. So in other words, if my a coefficient is positive, then I know it opens upwards. And if my a coefficient is negative, I know it opens downwards. Okay. Then what I can do is I can essentially make a table if I want to get any more specifics on it. But if I don't, I can just draw my shape. Well, I know it opens up like so. And if I did make a table and needed to get more specifics, well, I'd want to pick values on either side of what? Well, not 0, not the y-axis anymore, because notice my axis of symmetry is over here at x equal to -2. So I'd want to pick values maybe on either side of that, say 2 units away, -4 and 2. And let's just go ahead, and 0. So notice each of those are 2 units away from -2, right? -4 is 2 units in the negative direction, and 0 is 2 units in the positive direction. And I can always evaluate, say, one of these, f of 0, 2 times 0 squared plus 8 times 0 minus 1. Well, that's 0 plus 0 minus 1, that's -1. So my parabola actually should go through right there. I have the shape pretty close. I'd want to have it go through there. Okay, so if we need specifics, we can always get those specifics by making a table and picking values on either side of that axis of symmetry. But remember now, we're not always going to pick values that are on either side of the y-axis, because we're going to have shifts left and right in this condition. Okay, so we want to pick values on either side of that axis of symmetry. Notice 0 is 2 units away from -2 to the right, and -4 is 2 units away to the left. Okay, so let's now continue and look at some qualities of this graph. For example, domain, range, this idea of a maximum or minimum, and then where is it decreasing and where is it increasing. Okay, how about domain? Well, my domain is going to exist on all x values, and as this goes up, it'll go to the left, and as it continues to go up here, it'll go to the right. So that would go to positive infinity and negative infinity, and exists in the middle, so you're right, all real numbers. Now, how about range, y values? Well, my y values, notice it comes down here and then goes back up. So the y values are going to be bounded by this vertex here. So the vertex is either the lowest point or the highest point. In this case, it's the lowest point. So all of our y values are how? Greater than or equal to -9. Okay, looking at, of course, the y value of my vertex there. And remember, it touches there at -9, so it's also equal to. Okay, and then at this location here, this vertex, is that a maximum or a minimum? Well, that's the lowest it's going to be, so that's called a minimum. Now, if it opened downwards, you'd have, say, a maximum, but it opens upwards here with a positive a coefficient here. That's what made it open upwards. Okay? And so it's a minimum at, and you'd say y equal to -9, okay, at the y value of that minimum or maximum. Okay, where is it, say, well, what's happening here? Well, that would be called decrease, okay? So it's decreasing when x is how? Well, if x is equal to -2 at my axis of symmetry, then that would be all values when x is less than negative 2. In other words, all values on this side of the axis of symmetry, it would be considered to be decreasing. And conversely, as it goes up this way, it's increasing, and that's all values on this side of my axis of symmetry, so that's all values x greater than negative 2. Okay, so we want to be able to identify all these characteristics on a graph once we've, say, graphed it, or even just by, say, looking at the leading coefficient. Say I know it opens upwards, then I'm going to have a minimum and that kind of thing. Okay, let's finish by looking at a graph and see if we can't identify some of those characteristics, say, just from a graph here. Okay, so if I maybe had this parabola opening downwards, well, this line here would be called its axis of symmetry. Well, that's x equal to 3. How about this point? What's that called? Yep, vertex. And that's at 3, 1. Okay, where is it increasing? On which x values? Well, this would be increasing this way, which means that's x values less than 3. And how about decreasing? Well, that would be all these values going that way. And that's x values greater than 3. Okay, do we have a min or a max? Well, this one opens downward, so it's got to be a maximum. And that's at where? At y equal to 1. Remember the y value of your vertex here. Okay, domain. Range. Domain, you got it. All reals. Typically for these they are all real numbers. How about range? Well, y less than or equal to 1. You got it. The y value, the highest it's going to get is that maximum at y equal to 1. It's going to increase when x is less than 3 and decrease when x is greater than 3. Our axis of symmetry is x equal to 3. And what would its a coefficient be on this one, positive or negative? Well, a would be negative, wouldn't it? Because it opens downwards. Okay, so I hope this helps you get started. And remember, the key whenever you look at any of these, say, equations is to look at x equals negative b over 2a to begin. And that's your axis of symmetry, your AOS. And from there, you plug in that x value to get the y value, say, of your vertex. Okay, and b is always the coefficient in front of the term with x in it, and a is the coefficient always in front of the term with the x squared. Okay, thank you.